Hello, Lovelace. Welcome to today's maths lesson, continuing our work on fraction subtraction. And in particular, today we're looking at mixed numbers. Can we subtract two mixed numbers? Okay. As usual, though, let's start with a little warm-up. 5 questions today. Pause the video, have a quick go at these. Right, well, the first one, if there is anyone out there who gets this one wrong, then we need to have a long, hard look at ourselves. 4 takeaway 1 is 3. The only reason we've thrown this in is because there are going to be some whole numbers and fractions in our mixed numbers. What about number 2? Well, first job, we've got 7/12 take away 1/6. We need that common denominator. Remember, addition and subtraction of fractions can only happen if we have a common denominator. So we've got 7/12 take away 2/12, which is, of course, 5/12. Now, 3 and 4. 3, we've got a mixed number. 4, we've got improper fractions. So let's see which we are happier with. Well, for 3, let's start with the whole numbers. 4 take away 1 is 3. And then we've got 7/12 take away 2/12, because that's what the same as a 6. So 7 take away 2 is 5/12. So 3 and 5/12. What about as a mixed number? Sorry, not as a mixed number at all, as an improper fraction. Sorry. We've got our common denominator, so we can just do 55 take away 14, which leaves us with 41 over 12, which is a big, ugly, improper fraction. So let's sort that out. 41 divided by 12. Well, 12 goes into 41 3 times, with 5 left over, so 3 and 5/12. And for number 5, what do you notice about 3 and 4? Well, we notice they've got the same answer. In fact, we've got the same fractions. 4 and 7/12 is equivalent to 55/12. And 1 and 1/6 is equivalent to 14 over 12. So actually, these are both the same calculation, just presented in slightly different ways. Okay, first question. 3 and 3/5 take away 1 and 8/15. Well, job 1, well, we're going to split them up first of all. We're going to deal with the whole numbers first of all. So 3 take away 1. And then the fractions, 3/5 take away 8/15. So by partitioning, by splitting the calculation, hopefully it's a little bit more manageable. So in this case, 3 take away 1 is 2, duh. And then the 3/5 take away the 8/15. We need to do our common denominator, so we'll turn everything into 15ths, times top and bottom by 3, gives you 9/15. 9/15 take away 8/15 is 1/15. So altogether, our answer is 2 and 1/15. Now that method will work for some calculations, and we're going to look at different ways of calculating these types of questions, different ways of presenting them. Okay, so this is the part whole where we're dealing with part of the calculation at a time. First of all, we can deal with the whole numbers, then we deal with the fractions. Here's the same question, 3 and 3/5 and 1 and 8/15. This time, we'll start by converting to a common denominator, so that 3 and 3/5 becomes 3 and 9/15. And we'll have a look at it as a bar model. Okay, so our 3 and 9/15 as an improper fraction is 54/15. We know that because we do 3 lots of 15, which is 45, plus the 9, which is 54. 1 lot of 15 is 15, plus the 8 is 23. Okay, so we've now got our calculation as an improper fraction, 54/15 and 23/15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's our 3. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our 3. Up to that point there is our 3 and 9/15, or our 54/15. And then we've taken away 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we're left with 31 15ths. Now that's a big, ugly, improper fraction. We ask ourselves, how many times does 15 go into 31? It goes twice with 1 left over. So 2 and 1 15. 2 questions here. Have a think how you would approach those. Well, the first one, once we've created our common denominator, we've got 5 and 9 14ths, take away 3 and 4 14ths. Now, our fraction part means we don't need to cross the whole. We've got 9, take away 4. So this one we can do as our part whole. We've got 5 and 9, take away 3 and 4. So the 5 take away 3, we can deal with our whole numbers quite easily. And then our fractions, 9 14ths, take away 4 14ths, we can do. It doesn't interfere with the whole numbers. So 5 take 3 is 2. There's our whole number. And then 9 14ths, take away 4 14ths, is 5 14ths. So the part whole model will work with this one because our fraction in the first number is bigger than our fraction in the second number. That's not always the case. So if we look at the second one, 2 and 1/2, take away 1 and 1/6. Common denominator, 2 and 3/6, take away 1 and 1/6. This time let's look at it as a bar model, and there's our 2 and 3/6. Take away, or 2 and 3/6 is the same as 15 over 6. Take away 7 over 6, take away the 7, we're left with 8/6, or 1 and 2/6, or 1 and 1/3. Okay. Right, your turn. Pause the video, have a go at these. Oh, let's have a look. What happened to number 1? Okay, so Amir and Alex are working out 3.5, take away 2 1/4. Amir says, first subtract 2 from 3, then subtract 1/4 from 1/2. That leaves 1 1/4. Alex says convert an improper fraction first. So 7 over 2, take away 9 over 4. Then 7 over 2 becomes 14 over 4, take 9 over 4, which is 5 over 4, which equals 1 1/4. Whose method do you prefer? Now, this is totally personal choice, guys. What I would say is that if you convert to an improper fraction, you will always be able to do the calculation. If you do it as the part whole, it only works when the first fraction is bigger than the second fraction. Okay, so if you just want to have one method in your as a technique, then improper fractions might be the way to go. But it's whichever you're confident with. Mixed numbers, that's fine, but your first fraction needs to be bigger than your second fraction. Otherwise, you're crossing over wholes and it can get quite complicated. Right, answers to question 2. 2a, the answer is 2 1/2. If you've left it as 2 5/10, you're still correct, but do look for that simplification. For B, 2 3/8. C, 11 1/4. And D, 5 5/12. Question 3, car A travels for 15 1/4 miles, B travels for 21 5/12 of a mile. How much further does B travel than A? So we're going to do 21 5/12, take away 15 1/4, and you should get 6 1/6, or 6 2/12 if you've not simplified. Okay, now from Jack's house to school, it's 2 1/4 kilometers. From Jack's house to the park, it's 1 5/8 of a kilometer. How much closer is the park to Jack's house? So what's the difference between these two numbers? There's school, 2 1/4, and there's the park at 1 5/8. So this is what we're trying to work out, the difference between the park and the school. Okay. What calculation will you do to find that missing number? Well, there's a calculation, 2 1/4, take away 1 5/8. Have a think, how are you going to do that? Well, there it is, 2 1/4, take away 1 5/8. Let's start with the common denominator. The 2 1/4 becomes 2 2/8. We're multiplying top and bottom by 2. So we've now got 8 and 8. We've got 2 2/8, take away 1 5/8. Okay. Now, the problem here you'll see is if we do 2 take away 1, then 2/8 take away 5/8, we can't actually do that. We're crossing whole ones. So this is where it gets a little bit trickier. Okay, so what I would suggest, and what works all the time, is converting to improper fractions. Because we know that 2 2/8 is bigger than 1 5/8. So we know we can do the calculation, but we can't do it as a part whole method. We can't deal with the 2 and the 1 and then deal with the fractions. It won't work. So by converting everything to improper fractions, it becomes a little bit more straightforward. So think back to how we create an improper fraction from a mixed number. We multiply the whole by the denominator. So 2 8s are 16. Then we add the numerator. So 2 8s are 16 plus 2 is 18 over 8. The denominators always stay the same. And then 1 5/8 is 1 times 8, which is 8, plus the 5 is 13. So we've got 18 8s, take away 13 8s, which is 5/8. Once you get to that stage, very straightforward. So Jack's house is 5/8 of a kilometre closer to the park than it is to school. Right, so 2 2/8, take away 1 5/8. Let's look at it as a bar model. There's our 2 2/8. Now, another way of looking at that, and I know this is an ugly, ugly fraction, but taking one of the whole ones and turning it into 8 8s. So we've now got 8 8s and 2 8s. So we've got 10 8s, 1 and 10 8s, take away 1 5/8, which leaves us with 5 8s. So it's another way of looking at it. If you don't want to turn into improper fractions, that's another way of looking at it. So have a think about how you would approach these two. Well, the first one, we start with our common denominator. So our 3 3/5 becomes 3 6/10. We've now got 5 1/10, take away 3 6/10. Let's turn them into improper fractions. 5 10s are 50 plus the 1 is 51 over 10. 3 10s are 30 plus the 6 is 36 over 10. 51 take away 36 is 15 over 10. And then we can simplify that into a mixed number of 1 5/10, or 1 1/2. Now, what about this one? 9 2/7, take away 7 6/14. Now, for this one, again, let's start with our common denominator of 14. So our 9 2/7 becomes 9 4/14. We've multiplied top and bottom by 2. But this time, rather than create improper fractions, I'm just going to steal one of the whole ones and add it to my fraction. So instead of 9 wholes, I've now got 8 whole ones and I've added 14/14. I've added the whole one to the fraction. So 14/14 plus the 4 that we've already got gives me 8 18/14. Now, it is ugly. We would never actually represent a fraction like that. But even so, it's still the correct value. 8 whole ones and 18/14. Take away the 7 6/14. So now we can do the part whole. 8 take away 7 is 1 whole one. And then 18 take away 6 is 12. So 1 12/14. And that will simplify to 1 6/7. Okay. Two different methods, whichever you prefer. I know I do prefer the improper fraction one. I think it's a little bit tidier, a little bit clearer, but it's always good to be aware of other methods in case a question is presented in a certain way. Okay, so well worth checking out the different methods, but equally it's okay to have a preference. Right. 3 questions for you. Pause the video, have a go at these. Okay, here's your answers. Amir and Dora are working out 4 1/5 take away 1 2/5. And Amir says you can't use my method because you can't do 1/5 take away 2/5. Do you agree? And then I know that 4 1/5 equals 3 6/5. How does this help? Well, basically, Amir can't do it his method unless he uses this bit of information that Dora's created. Okay, 4 1/5 is the same as 3 6/5 because she's stolen 1 from the whole numbers and turned it into 5/5 and then added it to the fraction. So now you can do the calculation. Okay, but anyway, to help do the calculation, we've now got 3 take away 3. I'm sorry. We've now got 3 take away 1, which is 2, and then we're left with the 6/5 take away the 2/5, which is 4/5. Okay, so completing it, 2 4/5. Question 5. A is 1 9/10. B is 1 7/8. C is 2 1/2, once I'm out of the way. And D is 7/9. For C, if you've forgotten to simplify, you will have got 2 7/14. And for D, you would have got 14 18. And for 6, Dexter is subtracting fractions. Explain the mistake that he's made. Okay, well, he's come up with his common denominator. He's got 4 6. So 5 take away 3 is 2. That's fine. And then he's got 4 6 take away 5 6 is 1 6. So he's got that the wrong way around, hasn't he? Okay, so yeah, he's got 4 6 take away 5 6 equals 1 6. So there's his mistake. However you've decided to explain that, that's what's gone wrong there. Now, for those of you who are up to it, there's 3 more tricky challenges here. So let's see if anyone has a go at these 3. Pause the video, have a go at these as our extension for today. All right, well, here are the answers. Here are some number cards. Use 2 of the number cards to find the smallest difference. Well, the smallest difference between those will be 1/3 using the 2 4 cards. And then the difference closest to 2 is 4 and 5 6. Take away 3 1/12 gives you 1 3/4. So 1 3/4 is as close as you can get to 2. Right, the magic square. Each column and each row totals 5 7/20. So our missing numbers are 2 1/4, 2 3/10, 1 11/20, 2 2/5, and 1 2/5. Do look, I mean, if you're attempting question 8, you should be simplifying all your fractions. I'm looking for those answers. Okay. And then number 9, a marathon is 26 1/5 miles. Dexter has run 18 1/10. Eva's run 19 3/5. How much further has Eva run than Dexter? 1.5 miles. And how much further does Eva need to run? She's still got 6 3/5 of a mile to go. Well done if you've got some of those correct. They were some tricky ones. Okay, but that is the end of today. Look after yourself, take care of those around you, and I will see you very soon.